everyone, in this session we will be starting a very new concept that is called concept of deadlock, and we will discuss each and every concept related to deadlock in detail from the very basics to advanced level. So first you need to listen me carefully, then I will give you the time to note down. Okay. So the very basic question can come in your mind, how you can say that the processes are involved in deadlock or the processes are not involved in deadlock. Okay. So we will see each and everything from very basic, guys. So I am going to give you the definition of deadlock. Okay, I will give you two definitions, and I hope you understand clearly how you can say that the processes are involved in deadlock, and we will see through the resource allocation graph RAG, and through the resource allocation graph you are easily to identify the given sequence is in deadlock or deadlock free. Okay, I hope you understand clearly. So first listen me carefully. If two or more than two processes are waiting on some events to happen, but that events never happens, then what we can say that? Then those processes are said to be involved in deadlock. Understand? Waiting on some event. Okay, when it will happen, then that event will free the resource and we will use, but that events never happens. So that's why we are saying those processes are said to be involved in deadlock. This is the first definition I will give you here, don't worry. And the second definition is what, my dear friends? If two or more than two processes, okay, have some resources and waiting for the other resources which is held by some other processes, then we can say that system is in deadlock. Then we can say that processes are in deadlock. Okay, understand clearly? I hope these definitions are sufficient to understand how you can say that processes are involved in deadlock. And I will give you some basics of deadlock, guys. Don't worry, just listen me carefully here. You will get everything here. So I am going to start here, my dear friends, concept of deadlock. Concept of deadlock. Very important topic from the gate point of view, guys. Okay. So when we will finish this concept of deadlock, then approximately 40 to 50% syllabus completed of the operating system. Okay. So as I told you, my dear friends, as I told you, okay, if two or more than two processes, are waiting on some events to happen, but which never happens, okay, then those processes which are waiting on some events to happen, then those processes are said to be involved in deadlock. Understand clearly? And I am going to give you some other definition, my dear friends. Listen me carefully. So first need to note down this one. Okay. As I told you, if two or more than two processes hold some resources or have some resources and waiting for some other resources which is held by some other processes, then you can say that the processes are in deadlock, then you can say that the processes are in deadlock or system are in deadlock. Okay, if this is the second definition, please note it down. If two or more than two processes holds 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 some resources and waiting for other resources which is held by which is held by which is held by some other processes then 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 you can say that then you can say that processes are in deadlock. Then you can say that processes are in deadlock. Processes are in deadlock. So these are the definitions, my dear friends. These are the definitions. First, here I will tell you some basics, okay, of deadlock. Then I will move further, okay, and you are easily understand where is deadlock and where is not deadlock. Okay. So please note down these points. Then I will move next, my dear friends. So here I am giving you just offline classes feel, live classes feel. I am interacting you more and more. Okay. So I hope you understand clearly. Now I am going to you can understand the deadlock like this. I will you can understand the deadlock, okay, like this. Okay. So here I am going to give you an example through the resource allocation graph, but I will tell you the basics of the deadlock, means how you can form the resource allocation graph, what is requesting as, what is allocating as, okay, what are the resources, single instance type resources, double instance type resources. Okay, understand? I will discuss each and everything here. Okay, I will discuss each and everything here, my dear friends, don't worry. Okay, so you can understand the processes are in deadlock from this example. Suppose we have two processes, P1 and P2. Suppose we have two processes, P1 and P2, and we have two resources. We have two resources, R1 and R2. We have two resources, R1 and R2. Okay, R1 and R2, and here we have two processes. Okay, here we have two processes and we have two resources. Suppose this R1 resource allocated to P1, but P1 also requires for its execution what? It is also demanding what? It is also demanding what? Resource R2. It is also requesting what? It is also requesting resource R2. Okay, it have R1, but with the help of R1 only it is not able to execute itself. Okay, it also for its execution it also need what? Resource R2, which is allocated to another process P2, which is held by the another process P2, okay, and similar case here happens. Okay, P2 have the resource R2, but it is not sufficient. Okay, with the help of only resource R2 it can execute itself. For its execution it also requires what? It also demands or requesting resource R1, which is held by the another process P1. Okay, so now this system, now this situation is in deadlock. Now here P1 and P2 both are in deadlock. Now here P1 comma P2 are in deadlock. Okay, so like this we will solve various example, don't worry. Okay, so first I am going to tell you what is the resource allocation graph, how you can make the resource allocation graph. Okay, so understand clearly. So now I hope you noted down, guys. I hope you noted down. Okay. So now I am going to give you some basics of deadlock. Okay. Basics of deadlock. Basics of deadlock. Basics of deadlock. Basics of deadlock. Okay. Basics of deadlock. Basics of deadlock. Okay. Basics of deadlock. Understand? Suppose we have two processes. Okay. So in resource allocation graph, resources and processes need to represent what, my dear friends? Need to represent what? Vertices. Understand? And requesting and allocating need to represent what? Request and allocation need to processes request and allocation need to represent by edges. Okay, need to represent by edges. Okay, so need to represent what, my dear friends? Need to represent by edges. So suppose we have two processes. Suppose we have two processes. Okay, two processes P1 and P2. We have two processes P1 and P2, and we have three resources. We have three resources R1, R2, R3. So here resource R1 have only one instance like this. If anything represent like this, the meaning of this, if any resource represents like this, if any resource representation is like this, okay, if any resource representation is like this, what does that means? Resource R1, what does that means? Resource R1 has only one instance, means it have only one copy of resource R1. It can satisfy only one process. Okay, and what is the meaning of this? Suppose resource R2, suppose any resource, here I am taking R2, suppose any resource like R2 represents like this in the resource allocation graph. What is the meaning of this? Means here resource R2 has two instances of R2. Okay, it has two instances of resource R2. Okay, so what does it means, my dear friends? Resource R2 has two instances of R2. Only one instance of R2. Okay, of R2. Understand clearly? Understand, my dear friends? I hope you understand clearly what is the meaning of this. Okay, and if any resource represents like this, suppose here I am taking resource R3 and it represents like this. Okay, like this. Okay, so I am giving you all the basics. Okay, these basics will help you to identify, okay, the resource allocation graph. So what does it means, my dear friends? Resource R3 has three instances. Understand clearly? Understand, my dear friends? Okay, so I am going to tell you what is requesting is. Okay, requesting is okay. Requesting is in RAG. How you can identify this is requesting is, and how you can identify this is allocating is. Okay, this is allocating is. Okay, understand? So what, my dear friends? Suppose in your resource allocation graph, okay, there is a representation like this. Here we have process P1. Here we are talking about requesting is. Here is a process what, my dear friends? Here is a process what? P1. Here is a process what? P1. Okay. So if the edge like this, 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 only one is, okay, towards the resource from the process. If only one is from the process toward the resource, means that means is what, that process is requesting that resource, one instance of that resource only. Okay, understand? I am explaining again. Okay, if from any process we have a directed edge towards the resource, on if we have only one is, that means that process requesting, okay, only one instance of that resource, only one instance of that resource. Okay, understand clearly? So I am going to write down here. Okay, I am going to write down here, please note it down. If we have a directed as towards towards resource, from process, that means that process is requesting, here we have only one is, okay, that process is requesting only one instance, only if one is there towards process to resource. Okay, that means that process is requesting only one resource, only one instance of that resource, only one instance of that resource. Okay, so here what, my dear friends, here P1 is requesting one instance of R1. What is the meaning of this? This is a general definition, but here if we will talk about this one according to this definition, requesting as definition. So here P1 is requesting one instance of R1, resource R1, one instance of resource R1, one instance of resource R1. I hope you understand clearly. Okay, if my dear friends, okay, if suppose here we have considered what, two processes P1 and P2. Suppose here this P2 process, okay, if two edges towards the resource, so here we have a resource R2, okay, in which we have two instances. Resource R2 has two instances, okay, two instances. Suppose if any process, if from any process we have two directed edge towards the source, towards the particular resource, then that means is what, that process requires two instances of that resource, If you want to note down, then please note it down. If we have two directed edge, please note it down, if we have two directed edge, okay, from any process towards a particular resource only, okay, particular means is R2 R3, towards a particular resource only, that means that process requires two instance of that particular resource. That means that process requires two instance of that particular resource. Okay, so what is the meaning of this one? Here I hope you understand clearly. Here process P2 wants two instance of resource R2, okay, resource R2. I hope you understand all these basics clearly. Okay, so if you want to note down, then please note it down, guys, otherwise I am going to move on further. Okay, so now I am going to tell you what about the allocation graph, my dear friends, about the allocation graph. I am going to explain the concept of allocation graph, allocation edge, not Requesting is and allocation is. How you can identify this as is what allocating is. Means this is as is allocating resource to any process. Okay, in the resource allocation graph. In the resource allocation graph. Okay, okay. So if in the graph, there is a representation like this, there is a representation like this. Okay, there is a representation like this. Means is what? Means is what? If you have a directed is, okay, if you have a directed is towards the process from the resource, listen me carefully. If you have a directed is towards the process from the resource, that means is what? That means that as is what allocating is, means resource is allocated to that process. Okay, so please note it down, the general definition. Okay, if you have a directed is, if you have a directed is towards the process from the resource that means resource, that particular resource is allocated. That means that particular resource is allocated to that process. Understand clearly, my dear friends? I hope you understand. So here only one is towards the process, means only it requires only one instance of resource R1. If you want to note down, then please note it down. Here we have one is from resource to towards the process. That means P1 only requires only one instance of R1. Okay, understand clearly? That means P1 requires only one instance of R1. If we have a representation like this, if you have a representation like this, my dear friends, here we have a resource what R2, here we have a what, my dear friends, resource R2, and as I told you, resource R2 has two instances, and if we have two edges towards what process, suppose here process P2, if we have two directed is, okay, towards the process, then that means is what? Here that means is what? Here P1 requires only, here P1 requires, process P1 requires one instance of, because one directed is only here, one instance of resource R1. One instance of resource R1. Okay, and what does it means, my dear friends? What is the meaning here? Here process P2 requires two instances of, I explained everything here, two instances of resource R2. Two instances of resource R2. I hope you understand all these things. Okay, so please note it down first, then I will give you here a note. My dear friends. So please put this note on your notebook. Please put this note on your notebook, my dear friends. Okay, and what are that note? That note, my dear friends? The resource allocation and the resource allocation and requesting will be representing using resource allocation graph. Okay, the resource allocation and requesting the resource allocation and requesting, okay, will be representing using using RAG, using resource allocation graph. Resource allocation, resource allocation graph. That is what? RAG. That is what? RAG. Okay. So RAG equal to what, my dear friends? RAG graph is a combination of vertices and edges. So RAG equal to what, my dear friends? RAG equal to what, my dear friends? G, V comma E, B comma E, where V is what, my dear friends? Processes. As I told you, in the resource allocation graph, V represents what? Vertices represented by processes or comma resources. And E represents what, my dear friends? Edges. Okay. Requesting and allocation. E represents what, my dear friends? Requesting and allocation. Understand clearly, my dear friends? Understand clearly. So please note it down, please note it down, my dear friend, these points. Please note it down. Hello. Understand, my dear friends? So based on resource allocation graph, okay, based on resource allocation graph, I will give you some questions, okay, and need to find out, okay. Understand, my dear friends? Understand clearly? Understand? Okay. And need to find out the safe sequence. Means there in resource allocation graph there is a deadlock or not. If there is a deadlock, then no problem. If there is a deadlock, then find out the safe sequence. My dear friends. So now I am going to give you some question, my dear friend. Now I am going to give you some questions, okay? And I hope you are able to understand. Okay. Now I am going to solve some questions, okay, based on the RAG, resource allocation graph, which we have discussed in detail. Okay, understand? So these are the questions, and you can see the resource allocation graph. You can tell, okay, system is in deadlock or not, means processor in deadlock or not. Okay, so this is a small RAG graph, okay, resource allocation graph, okay, but some RAG resource allocation graphs are complex. So there are difficulty to find out system is in deadlock or not. Okay, so here you can see it directly, and you can give the answer. This is what this pair here P1 P2 are in deadlock or not. Okay, mean this system is a deadlock or not. Directly we can say that the system is deadlock. directly we can say that the system is in deadlock. The system is in deadlock. Okay, because R1 and R2 both the single instance type resources. Okay, and here P2, here resource R1 is one instance allocated to P1, but this is not sufficient to P1. P1 also requires, okay, P1 also requires what, one resource of one instance of resource R2, but it is allocated to P2. Okay, so that's why P1 is not able to complete their execution. Similarly, process P2 allocated one instance of resource R2 and it requires another instance of resource R1 which is allocated to P1. Okay, so this system is in deadlock. But if you want to play safe, then here we need to write here what processes. We need to write here what processes. Process how much P1, P2. You need to make table. Okay, and allocation. Okay, allocation of resources. How many resources we have? R1 and R2. R1 and R2 and need. Okay, here we need to write what allocation and need. Okay, need of R1 and R2 by process P1. Okay, so P1 allocated one resource of R1. Okay, yes, one resource of R1. Okay, and it doesn't have any resource, doesn't have allocated any resource of R2. Yes, 0. Okay, P1 requires more resource of R1 and more instance of R1. No, 0. It requires one instance of R2. Yes. Okay, this is P2, this is P2. Okay, so P2 allocated one instance of resource R2 and it doesn't allocated an instance of resource R1. Okay, but it demands, it need, and it doesn't need any resource of R2 more. Okay, like this. So both are, R1 have one instance and R2 have one instance. Okay, so R1 is allocated. Okay, available how much? Available instances of R1 and R2 how much? R1 and R2 how much? 0, 0, 0, 0. So no one process can execute. No one process, okay, can fulfill their demand. Okay, through this available R1 and R2. Okay, so this is in deadlock. That's why this is in deadlock. I hope you're understanding. P1 requires this need, okay, for their execution. 0, R1, yes, this is satisfied, but it requires one instance of resource R2. But here total availability of resource R2 is what? 0. Instance of availability of resource R2 is 0. Now this way you can see. Okay, so this is in deadlock. I hope you understand clearly. So if you want to note down, then please note it down. Next question I will give you. Okay, and try to solve by yourself. Okay, to get the confidence over the question. Okay, and this table will also help you in Banker's algorithm and deadlock avoidance mechanism. Okay, we will discuss later, my dear friends. But like this way you can check easily. Okay, like this way you can check easily. So if you want to note down, then please note it down. Otherwise, I am going to move on next question. I hope you noted down, and this is a very simple question. Directly by seeing the graph, you can say that this is in deadlock. Okay, or you can make the table like this. How much resources allocated to process P1 or of every type of resource, and how much it requires of every type of resource for its complete execution. You need to make the table like this. And my dear friend, this is next question, and I hope you are able to solve this question directly by seeing this RAG graph. You can give the answer of this question. Okay, but as I told you, if you will make table, okay, means every process requires how much resources of every type and how much resources allocated of every type. Okay, then this is very simple. You all are, and you are able to find out the step sequence also. Okay, so giving you here 2 minutes, just go and find out the step sequence. Just find out the step sequence. So directly you can solve this question directly, my dear friends. First try to solve directly, then make a table. Okay, so but when the system is complex, when the RAG is complex, okay, then table will help you to identify system is in deadlock or not. If not, then table will also help you to find out the safe sequence. Okay. When any process will execute itself, then it will release the resources. Whatever it holds, okay, it release the resources, okay, after execution. So try to solve this question, my dear friends. Try to solve this question. So I hope you got the answer of this question. Okay, guys. So directly you can see from the resource allocation graph. Okay, this P3 requires only one resource, only one instance of resource R2. It doesn't need after this. It doesn't need any type of instance of any resource. Clearly, you can see here. So P3 will execute first. The system is not in deadlock. Not in deadlock. Not in deadlock. Okay, not in deadlock because P3 is able to execute itself. P3 is able to execute itself because P3 requires only one instance of resource R2 only. It doesn't require any other instance of any resource. So P3 will execute. So when P3 will execute, then it will release. Then it will release this one instance of resource R2. Then now P1 can execute because P1 have one instance of resource R1, and it demands one instance of resource R2. So when P3 will leave this one instance of resource R2, then it will allocate it to this P1. So now P1 is okay. Now P1 is executed. Now P1 is executed. Okay. After this, P2 have one instance of resource R2, and it is demanding, okay, one instance of resource R1. So when P1 is completed their execution, so it will release this instance of resource R1, and it will also release this instance of resource R2 also. So P3 is also able to execute. So my dear friend, this is the safe sequence. This is the safe sequence. Okay. If you want to solve it by the table, then here you need to write down the processes. Okay. So how many processes we have? P1, P2 and P3. Every process allocated. Allocation you need to write down here resource R1, R2 and R3. Okay, only R1 and R2, not R3. Only R1 and R2. Okay. So this will help you understand when we will solve the banker's algorithm in deadlock avoidance. So okay. So P1 requires of resource R1 how many instance? Only one. Resource R2 doesn't have any instance. Okay. Here you can need of resource R1 and R2 for every process. Okay. So P1 is demanding any resource of R1? No. It is demanding one resource of R2? Yes. P2 allocation, P2 allocated one instance of resource R2. Okay. And it is allocated any instance of resource R1? No. Demanding one instance of resource R1? Yes. Okay, demanding more instance of resources R2. R2, no. Come on, P3. P3 demanding only one resource of instance R2, only one resource of instance R2. Okay, and it doesn't demand any instance of resource R1, and no need after allocating one instance of resource R2, no need of R1 and R2 more. So availability, how many resource we have? R1 have one resource, one is allocated, so available R1 available 0 now, and R2 have two resource, both are allocated, so R2 available now, available resources R2 available resources is 0. So in this condition, which process we can execute? This process we can need available this one, and this will fulfill this need. Okay, so P3 will execute here. When P3 will release, when P3 will execute, then it will release the allocated resource. Okay, so now available resource we need to add. Now available resource how much? 0 1. P3 will release these allocated resources. So available resource now how much, my dear friends? 0 1. So in this resources, these resources fulfill which process demand? This process demand. Okay, so after P3, P1 will execute, P1 will execute, then P1 will also release their allocated resource. Okay, need to add here 1 0. Then available how much, my dear friends? 1 1. 1 1 is available, and this one will fulfill the requirements of my dear friends P2. So P3 will execute. Okay, and P2 will also release their instances. Then total availability is what, my dear friends? 0 or okay 1 and 2, which is original sources have instances of R1 R2. Okay, I hope you understand clearly. So these questions are very easy, my dear friends. No, okay. So P2 will also release this one 0 1. So 1 and 2. Okay, and R1 has 1. All the process executed, all the sources will release. So R1 have one instance, yes, and R2 have two instances. All the instances are released by R1 and R2. Now all instances are free. Okay, so I hope you are able to understand this question also. Now I am going to give you more question. This is your next question, guys. Try to solve it by yourself to get the confidence. Okay, and this is a very good question. The table will help you in complex RAG to identify the system is in deadlock or not. If it in deadlock, then no problem. If it is not in deadlock, then find out the safe sequence. So to find out the safe sequence, table will help you. Okay, so here I am giving you only 2 minutes. Just try to make the table and try to find out the safe sequence, or and tell me this is in deadlock or not. If this is not deadlock, then you are able to find out a safe sequence. If it is in deadlock, then there is no safe sequence. Okay, so I hope you are able to solve this question. Try by yourself, my dear friends. Try by yourself. Okay. So I hope you are getting the answer. So after this, I will give you some important concept about deadlock, and various times they ask the question from that concept questions in deadlock. Okay, and very simple. I will give you very clear cut picture. Okay, generally students interval about those questions, but here I will give you very clear cut picture. Okay, and we will solve various questions also. And at the last of all the concepts, we will discuss all the previous year questions from deadlock to get confidence over the deadlock. Okay. So I hope you got the answer. Okay, this isn't deadlock or not. I am going to find out. So here we have process how much P naught, P1, P2, P3. I am going to directly make the table P naught, P1, P2 and what P3. Here I am going to write down the allocation, okay, of resource R1, R2, R3 for every process, and after allocation how much they need for their execution of every type of resource R1, R2, R3. Okay, so P naught, P naught, P naught, P naught, P naught what, my dear friends? How many resource of R1, R2, R3 allocated to P naught? One resource of R1 allocated to P naught. Okay, one resource of R3 allocated to P naught. Okay, allocated to P naught. Okay, allocated to P naught. And any resource of R2 is allocated to P naught, my dear friends? No. This is the situation. So P naught requires what, my dear friends? P naught requires one instance of R3 more. Okay. P naught requires one instance of R2 more. It doesn't require an instance of R naught. This is the P1. P1, P1. Okay, this is P naught, this is P1, P1. P1 allocated R1, R2 type resource, allocated one instance of R1, R2 to P1, R1, R2, R1, R2 to P1, R1, R2 to P1. Okay, and any source of R3 allocated to P1, no. And what is demands? It requires only one more instance of R1 type. Okay, it demands any source of R2 and R3, no, 0, 0. Come on P2, come on P2. Okay, so P2, which types of resources allocated to P2, my dear friends? Okay, which types of resources allocated to P2? Allocated to P2. Allocated to what, my dear friends? P2. Okay, so P2. Okay, R2 type 1 resource allocated to P2. R2 type 1 resource allocated to P2. Okay, and there any resource of R1 type allocated to P2, any resource of R3 type allocated to P2, no, 0, 0. And what is demand? What is demand? P1 demand, P2 demands only one instance of R3. It demands any instance of R1, R2, no, 0, 0. Come on P3, come on P3. Okay, P3 only R2, one instance allocated to P3, and one instance allocated to P3. Okay, allocated to P3, and it demands two instance of R2 also. Okay, and no instance of R1 allocated to P3, no instance of R3 allocated to P3, no demands of R1 and no demands of R3. Okay, so how many resources of R1 is allocated to, and R1 have how many resource, how many instance? 2. So availability is what? R1 availability is 0. R2 allocated, my dear friends, 3. Allocated how much, my dear friends? 3. And okay, availability now 3 instance, and 3 is allocated. So R2 availability now 0. R3 availability is what, my dear friends? Okay, R3 has 2 instance. Okay, R3 has 2 instance and only one instance is allocated. So availability is what? One instance is available of R3. One instance of available of R3. Okay, so at this availability, we can execute which process, my dear friends? At this availability satisfies, okay, which process need? So this availability satisfies this process P2 needs 0, 0, 1. So P2 will execute here. This is the safe sequence. P2 will execute here. Okay, and after execution, P2 will release the allocation resources. So now available resources how much? We will add okay, 0, 0, 1. We will add this 0, 1, 0, 0, 1, 0. So it will become what? 1, 1, 0. Now that much of resources is available. So these available resources satisfy which process requirement or need? 0, 1, 1, 0, 1, 1, P naught. So P naught, okay, 0, 1, 1, P naught. So P naught will execute now. When P naught will execute, then it will also release the allocated resources. We need to add here 1, 0, 1. So 1, 1, 2, 1 and 1. Available resources that much. So that resources will satisfy which process? Which process need, my dear friends? P naught is completed, P2 is completed. Out of P1 and P3, out of P1 and P3, these satisfy which? Okay, which process need, my dear friends? So they will satisfy what? This P1 also. They will satisfy this P1 also, and this P3 not, because P3 requires two instances. Here only one instance is available. So first these available instances of R1, R2, R3 will satisfy the R1, will satisfy the P1 needs. Okay, so P1 will execute here. Now it will release their own resource. Okay, 110. So 110 need to add here 2 and 2. So that much of resource is available, and this will satisfy the demand of this one also. Okay, so after P1 we need to execute this P3. This is the safe sequence. This is the P2, P0, P1, P3. This is the safe sequence. Means when processes will run in this sequence, then they will come out from the deadlock. Means there is no deadlock. Okay. So when P2 will execute, when P3 will execute, my dear friend, then it will also release their resources. So we need to add here 0, 1, 0. Okay. So 2, 3, 2. Okay, 2, 3, 2, R1. All the resources are available now. All instances of resources are available now. So I hope you get the answer. This is the safe sequence. And now this way, you need to handle the questions of the resource allocation graph. Okay. So after this, I will give you a concept formula, okay, of deadlock, and we will see various questions from that formula, and various times they ask the question from that concept. Okay, then we will move further. Okay, so I hope you are able to understand. Okay, so if you want to note down, then please note it down first. So this is in not deadlock free system is deadlock free, and this is the safe sequence. I hope you noted down, guys. I hope you noted down. After this, we will move with what, my dear friends? With the concept formula, okay, and we will solve various questions on that formula. Okay.